factored, right? Everything is factored. 25, you would have to factor the top and bottom before you start. So 24, I'll do 24. We're trying to find out where x squared, what the hell am I saying? X minus 2 times x minus 1 over x minus 3. We want to know when that is bigger than, let's just say bigger than 0. Yeah, let's do just, we'll do what they're doing. All right, we want to solve this. All right, do we remember how to do this? Yes? Doing what? Yeah, I mean, I guess you could if you're comfortable with it. I wouldn't mind you doing that. I'm going to follow the procedure that I went through in class. But yeah, you could probably just go straight to a number line right now. Everything's ready on one side, so and factored, right? It's all factored. So the first step that I said is make this equal 0 first, right? Make this an equation first. So if we make this an equation first, and remember, we're not saying that this problem is the same as that problem. We're just saying we're going to look at this scenario first. And then the next step would have been to factor out everything, which it's already factored. And so once you get it equal to 0, I told you also that a fraction can only be 0 when? When the top is 0. So my next step is to say, okay, when is x minus 2 times x minus 1 equals 0? And you set each of those to 0, you get two answers, 2 and 1, right? And we also know that the bottom can't be 0, but I'll get to that in a second. I'm going to draw a number line right now. I'm going to put those 2 points on there, 2 and 1. Those are not vertical asymptotes. That's just me breaking up the number line into, right now, three sections. So I know right now that 1, if I plug 1 in, what happens? I get 0, right? I get 0. And do I want this thing to be 0? Yes. So I can have 1. Can I have 2? 2 can be there as well, because 2 makes it 0. But there's one number it can't be, and that's the denominator being 0, which would be 3, right? So 3 is here as well. I don't want that. But that does break up the number line into now 4 regions. Once you have your number line broken up, you've looked at everything that makes the top 0. You've looked at everything that makes the bottom undefined, or the bottom 0. You put those on a number line. Then you have to pick test points. And those test points that you pick have to be in those regions. So like 0 is a good test point. 1.5, I guess. 2.5. And let's go with 4. And what are you going to do with these test points? Plug them into the original and see if it's true or false, right? True or false. So let's plug in 0. 0 should be pretty easy to plug in. What happens if I plug 0 into this? I get 0 take away 2 times 0 take away 1 over 0 take away 3. This is a negative number. This is a negative number. This is a negative number, right? 2 negatives are positive, so I have a positive number over a negative number. That's a negative number, isn't it? Is a negative number bigger than 0? No. Right? See, I'm not actually even figuring out exactly what this number is. I'm just figuring out if the sign is positive or negative. It's faster if you do it this way. Questions on that? Negative divided by negative would be positive. So if the two signs are opposite, it's negative. If they're the same, it's positive, right? Negative over negative is positive. Positive over positive is positive. So does anything in this region work? No. Nothing here works. Now I have to check 1.5. Let me do it right here. If I plug in 1.5, 1.5 take away 2, 1.5 take away 1, 1.5 take away 3. Okay, this number is what? Negative. This number is positive, this number is negative. So the two top ones become negative, and the bottom is negative. Negative divided by negative is positive. Is a positive number bigger than 0? Yes. So that does work, right? Okay, I'm not going to show the next two, all right? But this doesn't work, this does work, all right? And so what we can say is that our answer is everything between those two numbers and everything in between them, and then also everything past 3 to the right forever.
How do we write it in notation?
Interval notation. So we'll write that as, our final answer here is our solution is the set bracket 1, comma 2 bracket, that's everything between 1 and 2, including the two endpoints, union, and then now everything past 3, but not including 3. So 3 to infinity, parentheses on both. All right, let's move on because of time. I strongly encourage you to go back and watch these videos or look at your lecture notes on how we did these, because these polynomial inequalities were a little different. Just a little bit, but they were different, all right? Okay. What's next on the review? Page 511. 4 through 6, 8 through 10. Let me go to 511. Four through 6. So on all of these problems, 4 through 6, you're supposed to find f of g, g of f of f, and g of g. So it's just showing that you understand composition. So look at those there. I think we should do the hardest one. I think 6 is the hardest one. Now, I don't think we have time to do all of them, like every single one, f of g and g of f and f of f and g of g. But let's at least do two. We'll do 2 of them. Or if you want, I'll do more. So now we're talking about composition, right? Composition of functions. So we have, we're given that f of x equals x plus 1 over x minus 1. And we're given that g of x is 1 over x. And let's do you want to do f of g or g of f? It doesn't matter? You don't care? We'll do g of g as well. But before that, f of g or g of f? G of f? G of f. G of f. Okay, let's find this. So first you got to know what that means, right? You got to know what that means. Goff, right? So this means g and inside of it f. If those were reversed, then this would be f and inside of it g. So it's like left to right. So now what I do is I leave the g alone, but instead of plugging in this symbol, I replace f of x with f of x. And now I'm going to take this and plug it into g. So that x right there, right, that x right there gets replaced with this thing. So let's write the g function down. The g function is 1 over the x, but what are we plugging in? This. X plus 1 over x minus 1. Right? And 1 divided by a fraction is the same as the reciprocal, so you can flip it over. And you're done. Let's do f of f. I think f of f is much harder than g of g. F of f. Foff. So this is f, and inside of f goes what? F. So I'm going to take f, and inside of it, I replace it with f of x, which is x plus 1 over x minus 1. Right? That's f being plugged into itself. Now, we're going to take this entire expression and plug it in right here for this, right? Which means this gets replaced with it and this gets replaced with it. It's going to look terrible. It's going to look absolutely terrible. It's going to be equals, all right, f is this big fraction, right? The top left corner is the green one up there, is this, right? So x plus 1 over x minus 1, oops. X minus 1. And then what? Plus 1. And then the bottom is also another x, so replace it with that, x plus 1 over x minus 1 minus 1. And we're done. Yeah, well, I mean, that is technically correct. I mean, this is not wrong. That is f of f. But algebraically, we can clean it up. So what I would do to clean this up is I would put these two together. And to do that, I would get a common denominator here. So I'd replace this 1 with, instead of 1, 1 over 1. Instead of 1 over 1, I would do what? X minus 1 over x minus 1. This is what we were talking about. Right? We want to use the same denominator here. And while we're at it, we're going to do the same thing on this one, right? This 1 down here, we're going to replace it with x minus 1 over x minus 1. Now these two can go together, right? And what we'll have is the common denominator on the bottom, and then on the top, we take this and add this. So x plus 1, and we add to it x minus 1. On the bottom, same old thing. Put these together, they have the same denominator. But you have to be careful here, right? Why do you have to be careful? You have a minus. So you're doing x plus 1, but you're subtracting x minus 1, right? And you must have this x minus 1 in parentheses if you're going to subtract it. So the subtraction sign goes through to both. I did not need that up here. I did not need a parentheses here. I could have put it there, but I didn't need it because it's a positive, and positive doesn't change anything. So up top there, I get 2x, just 2x, right? Over x minus 1. And on the bottom, what happens here? Careful, it's not 0. What is it? When you do this line right here, you get x plus 1 minus x plus 1. You get 2, because the x's cancel and the 1's add up. So you get 2 over x minus 1. And then that, we can flip, keep dot flip, keep the top fraction, change the division dot, multiplication, flip it. Now the x minus 1's cancel. 2x over 2, which is x. Ooh. That's an interesting result. What does that mean? What does that mean? We took f and composed it with itself and got x. It means that f is its own inverse. F is its own inverse. That's really odd. Because most functions, when you find their inverses, it's a different function. This function, when you find its inverse, it's the same function. In fact, if we were to graph it, this is just a side note here. If we were to graph it, what should the inverse of this function be? A reflection of itself over the identity, right? So let me show you what the graph of this looks like. X plus 1 over x minus 1. And now let me graph the identity, y equals x. I'll make that a dotted one. Check that out. Do y'all see that if I reflect that red function over that diagonal line, do you see that it lands right on top of itself? Which means it's its own inverse. Okay. Kind of interesting. All right, let's talk about the next thing. So it was page 511, 4 through 6. How about 8 through 10? So 8 through 10. Number 8, I'm not going to go through this one. This one says, hey, look at this function. It's 1 to 1. They want you to graph its inverse. So the inverse of this function is just a reflection over that line. So what you can do is you can take every one of these points, like 3, 3, 2, 0, 0, negative 2, negative 1, negative 3, and just flip the x and y coordinates and plot those points. And you would get the inverse function. Again, we did that in class. Okay, 9 and 10, I give you two functions, and I say, hey, verify that they're inverses of one another. So verify that they're inverses. So you do f of g of x, and you see if x comes out. We'll do number 10. How are we doing on time? We're okay. Yeah. Okay, so for number 10 there, they give you two functions. They give you f of x equals x minus 4 over x, and then they give you g of x is 4 over 1 minus x. And they ask you to show that they're inverses. Show that these are inverses. The way you show inverses, you have to show two things. We must show, first, that when I do f of g of x, that I get x. The second thing I have to show is that when I reverse it and go g of f of x, I get x. Those are the two things that must be shown. So let me do the first one. Let's do f of g of x. So f of g of x means f with g inside. That means f, what's g? 4 over 1 minus x, right? Now take that and plug that into f. You get 4 over 1 minus x minus 4 over 1 minus x. So, right, all I did was replace g with g, and then I took that and I plugged that into x right here, or sorry, into f right here and right there. I replaced both of those red x's with these two things. I have to clean this up, and I have to show that that's equal to x. So to show that that's equal to x, I'm going to rewrite this 4 as 4 over 1, and I'm going to get a common denominator between those two. So I will need what here and what here? 1 minus x and 1 minus x, there and there. So now that becomes 4 over 1 minus x minus, how do I want to do this? Let me just rewrite it first. 4 times 1 minus x over 1 minus x, and then 4 over 1 minus x. All I did there was just put those together into one fraction. Now let me put them together. So this will become 4 minus 4 times 1 minus x over their common denominator, but then all of that over 4 over 1 minus x. So since these had the same denominator, I just put the numerators together. Now I will distribute the negative 4 through. 4 minus 4 plus 4x over 1 minus x over 4 over 1 minus x equals, okay, I know I'm moving quick, it's a review, so we all right? 4's go away. 4x over 1 minus x, but all of that over 4 over 1 minus x. And then I can keep this and bring it up, right, like this. So let me go ahead and do that. I'll do it in purple. So when I flip that up, it's a 1 minus x on top and a 4 on the bottom, right? That's no longer there. And you see what happens now? Yep. 1 minus x goes, and then also the 4 goes. And you get x, which is what I needed to show. The good news in a problem like this is if you're asked to verify that they're inverses, you should get x. You'll know you got it right because you should get x at the end. If for some reason you're not getting x, that means something is messed up. I'm only halfway done. Now I have to show g of f of x equals x. So to do that, I'll do it right here. I do g inside f. So then I do g, but f is x minus 4 over x. Right, so I'm going to take, that's my f function right there, right? That's my f. I'm going to plug it into g, so I'm just going to slap it right there. This should be a little cleaner. Let's see. I have 4 on top, 1 minus, and then here's the f being plugged in. Equals 4 over. Okay, I'm going to put these together. I need a common denominator between these two right here. So I'm going to turn that 1 into 1 over 1, and oh, well, there, x over x. I'm turning that 1 into x over x. That way I can put those two together, right? So it becomes x take away what? Take away what? X take away that, right? Better put in parentheses. 4 over, okay, what does that denominator below the 4 become? What does that become? What's x? Take away that. Just 4, just becomes 4. The x's cancel, so you have 4 over x down here. And then this is a little weird, but you need to understand this as a fraction. This is really 4 over 1 over 4 over x. That's really what that means, 4 over 1 over 4 over x, and then you could keep dot flip again. So 4 over 1 times x over 4. 4's cancel, you get x, we're done. All right? All right, the next thing on here, so this next section, page 512, is really a lot of material, all right? 512. So for 512, what do I say here? 512, numbers 11 through 13. Let's look at these. 11 through 13. What am I saying? Find the inverse of the function. Find the inverse. That means you're not given the function. You're not given the inverse. You're just given the function. You're told it's 1 to 1. You're asked to find the inverse. You all remember how to do that? There's a whole set of steps.
It's like f to the negative.
That's what you're looking for, yes. So first thing you do is you replace f of x with y. Then you switch x and y. Then you solve for y. All right? Please be able to do number 11. 11's the hardest one there. Be able to do it. We did one in class. I want to keep talking about what's on the test. Numbers 18 and 19. Find the domain of a log function. I give you a log function, what's its domain? Well, what do we know about logs? What's inside of it must be positive, right? So you're going to solve that. Again, look in your notes. We went over this. This log, we would have to take this inside and make it greater than 0. That's a quadratic inequality, which you should know how to solve. We've done that in class. Let me see the next one. 23 through 29. 23 through 29. This comes from last class. Look at number 23 through 26 there. All of those, it says to express it as a sum or difference. I use different language in class. Okay, in class I didn't say express as a sum or difference. I said expand. These problems right here are telling you to expand these expressions. So take it from a single log and take it and pull it apart into a bunch of logs. And then when you get to 27, what was it, 27 through, 29? 27 through 29 is the opposite. We're condensing. They say express it as a single log. That just means condense it, all right? Condense it down to 1 logarithm. We did a little bit of that today, right? A little bit, but a lot of it last class. And then, let's see, 32 through 33. 32 through 33. These are where you had to graph some exponential functions. I did some problems there. That was like shifting, where you go up, down, left, right, reflections. Those are not super important to me. What's important to me is the next part, 36 through 49. That's a big, very important topic for me on this test. Unfortunately, it's what we just talked about, right? So you're not going to have, you just have the weekend. So look at this, all these problems right here. What was it, 36 through what? Through 49?
Was it 6.6?
Oh, you know what? It was supposed to be through 45. Sorry, not through 49. Through 45. Actually, 46. It's supposed to be 36 through 46. Look at all those. These are all equations. See all these equations? They're either exponential equations or log equations. They're one or the other. Last class we solved exponential. Look at 36. What's 36? What type of equation? Exponential. 37. Exponential. 40. Exponential. 41. Log. 44. Log. 45. Exponential. You should be able to work through those. And now, if I'm not mistaken, maybe I am, I think there might be answers to these problems. Let me see. Let's see what the back of the book has here. There's answers. So, oh, the chapter reviews actually have evens and odds, it looks like. Hold on. So I actually have to scroll through this, unfortunately. I'll tell you what page this is on once I find it. Chapter 2. Oh, it's going to take a while. Because we're in chapter 6, right? There's no easier way to go through these pages. What a pain in the ass. 4.2. I just want to confirm, because all these problems are coming from the chapter review. So let's go to the chapter 6 review. That's where most of this is. Wonder, can I change that number? 40? Ooh, it does let me do that. Chapter 6. I'm trying to get to the page that'll have the answers for you, so just hang tight. Oh, 7. How did I get that far? There we go. Review exercises. Assessing your understanding. Review exercise. Okay, so there it is. It's on, do y'all see that on the bottom there? It's AN, that means answer, AN 46. AN 46 is where the chapter 6 review is coming from, all right? Now remember, you do have some problems from chapter 5. Those are the inequality ones. But most of the test is chapter 6. So you'll understand, you can go look at those problems. You can check your answers here. Yeah? All right, everyone. Well, yeah, study and, oh, reference sheet. Yes, I will allow you to have a reference sheet. Thank you for reminding me. I thought about it about 10 minutes ago and I forgot. So you may use one sheet of paper, front and back. You can write down, same thing as before, steps, procedures, formulas. You just can't work out. Do not work problems out. Don't work problems out. You can have the loop on there. That's fine. Just don't do specific problems. All right? All right, everybody, have a good weekend, but study. This is an important test. It's our last one before the final. So
Is the final gonna have everything combined?
everything.
Oh my God.
Every problem we've ever done in here is going to be on the final.
We're gonna drop our lowest test.
It's just going to be all your homework problems. Your final's going to be 300 problems long. No. It won't be everything. It'll be like the highlights, the things that I think you should really just kind of know before you move on. And I will let you know. I'll give you some
It's like
guidance.
an NBA game.
Yeah,
It's like the fourth quarters, and then it's like after the game, it's like the highlight.
that's right. It's going to be the highlights.
the highlight reel.
Okay.
The highlight
so
reel of the class.
After this class, what class should I take next semester?
Pre-cal is next.
Pre-cal?
Yep,
you're
that's
taking
the next in
Yeah,
line.
yeah, yeah. You teach pre-cal next semester?
I don't have a pre-cal for spring. Yeah, sorry.
I try to get him through, but
Yeah, I don't.
You're not doing calculus over the summer, right? 'Cause I try to get
Pre-calculus or calculus?
calculus over the summer.
I don't remember what my summer schedule is. I thought I had a calculus, but
Already
maybe
signed
not.
up Ryan's senior year.
Yeah. I don't recall my schedule at this moment.
Are you doing
But-
Cal 2 for next fall?
I'm pretty sure I'm signed up for Cal 2. You want to talk? Let me turn my microphone and this off.
Are you doing Cal 1 next fall?
I should.